Good evening, guys. Good evening. Anyone hearing me?
Evening, sir.
Pwede pa po.
Okay, sir. If you were talking this whole time, I wasn't hearing you.
Sorry. Shamar, were you saying something?
Yes, I was saying that if you were speaking this whole time, I was not hearing you.
Oh no, no, no. I had a challenge. I mean, this is my third time coming into the class because the microphone wasn't unmuting at all. So I haven't really started yet. Okay, Raji, I hear you. Um, Chevy, are you here? Mm, Ottilie's here. All right, cool.
Sir?
I sent you a message, Papa. Can you look at it for me, please?
All right, cool.
Mm. All right, so I'm just trying to, it's the start of the semester and I'm just trying to do some housekeeping matters just to get some stuff out of the way. So forgive me, guys. All right, so spoke with three. All right, Simon, can you check the chat for me, please? Simon,
Yes, sir.
check the chat for me, please.
All right. Okay. Oh, no, that's not. Um, Look, Chevy, look again for me, please. I sent you something a while ago. Tristan,
Sure.
you saw my message?
Yes, sir.
All right. Respond to me, please, in the chat. All right. While they are doing that, let me get ready. Oh, this thing needs to charge. Okay, Simon, noted. Still looking, Chevy?
Yes, sir, I'm not seeing it.
All right, cool. All right, so, all right, check again, Chevy. Sent you something into the chat. All right, so that should end my housekeeping. Ouch. All right, so based on what it is that we looked at on Wednesday last, are you guys comfortable with evaluating the limit of a function? Yes, no? Talk to me, please, somebody. All right. I'm not sure if you guys are hearing me.
Hearing, yes, sir.
Come
Yeah.
on, so respond to me, no man. I was asking, are you comfortable with now evaluating the limit of a function? Well, not you, but Tristan and the others. Are you here? Are you with me? Are we ready to go? Do you need a few minutes? What's the deal?
Yes, sir, I'm here.
Yeah, but I mean, I'm asking a question and nobody's responding.
Sir, in regards to the question, I wasn't here at the last class.
So say something to me. I just need people to talk to me. I can't be asking questions and then I'm here in perfect silence. Trust me. I've been up since morning. I would do well with some sleep. So let me know. And I remember I told you that we're doing something for 6 weeks, so we really don't have the time to tarry. So the longer you take to respond to me so that I can know you're with me is the longer it take to complete the syllabus. Your exam paper is already written and submitted, both for Calculus 1 and for Calculus 2. I have made my contributions to the exams long time, right? So I'm saying to you, we're ready to go. We're about to begin and need you guys. Come on. We don't have time to I can't even say, all right, you're so tired or not going home. I don't have that time. I don't have that luxury. I have to be moving.
Sorry, I'm hearing you, but I can't unmute all the time. Just
Yeah. Thank you, Arthur. All right. So now, my question was, are you okay with what it is that we did on Thursday, on Tuesday, on Wednesday?
Yes, sir, I'm okay with it.
yes,
You're
sir.
okay with it. All right, cool. All right, so allow me to what is wrong with this? To share. And we're gonna have a conversation. So the last time I think we ended right here. We ended right here the last time, right? We looked at those two questions, true or false?
True, sir.
Mhm. All right, so what I want to do is to do just one question with the intuitive approach, where the limit is tending to infinity. I want to develop a concept, and so I want you to be working with me. And that's my example 3. After my example 3, I'm going to go into some algebraic approaches. So let us look at example 3. We're asked to evaluate the limit. We're asked to evaluate the limit of x as x tends to infinity of x over x minus 5. In particular, those who are with me for the first time for Calculus 1, you all need to speak up, because some of the others would have already seen this concept or these concepts. So in particular, you need to speak up. I don't want anybody to say, oh, sir was moving too fast, so I didn't catch it. But when I'm asking a question, nobody's responding to me. All right, so please come, let's go. So we're asked to evaluate the limit as x tends to infinity of x over x minus 5. Now, I'm investigating the right-hand side. Now, an infinitely large number. Somebody will say, sir, when we talk about an infinitely large number, we talk about quadrillion and, septillion and all those wonderful stuff. But really and truly, once I'm talking about a rational function, and my rational function is my function that is in fractional form, I can speak of something going to infinity much quicker than calling even 100,000. I don't have to use 100,000 to do my representation in that. So let's just look at the left-hand side. I'm going to call my first number, my first infinitely large number, 10. But sir, 10 is not an infinitely large number. For a rational function, it is. For a rational function, it is. So let's just look at 10. And let us look at our function. Our function here says x over x minus 5. Wherever in the function I see x, I'm going to put 10. So this is why I have here now 10 over 10 minus 5. 10 divided by 10 minus 5 gives me 2. Because 10 minus 5 is 5. So 10 over 5 is equal to 2. All right? So I have a base from which to start. Let me look at a higher number and go to 100. Anywhere in the function I see x, I put 100. So this number becomes 100 over 100 minus 5. When I evaluate all of this, I'm getting 1.05. So you see what is happening? I'm moving from 2 to 1.05. Let us look at 1,000. When I use 1,000, I'm getting 1.005. 10,000, I'm getting 1.0005. And what do you think will happen if I use 100,000? What value do you think I'll get if I use 100,000?
$1.00005.
Very good. Excellent. And Shamari, let me ask you, where do you think that limit is tending? The answer to the left-hand side of the limit is going to be what?
Sending to 1.
Very good, sir. It's tending to 1. And I would agree with you. All right, I would agree with you. Let's just look at the left-hand side. Out of the left-hand side, I'm going to look at negative 10. I'm going to look at negative 10. And I'm calling my infinite large number there as negative 10. When I do that, I'm going to have negative 10 over negative 10 minus 5. So I'm going to have negative 10 over negative 15. And I'm going to get 0.6. When I use negative 100, I'm going to get 0.95. When I use negative 1,000, I'm getting 0.995. Negative 10,000, 0.9995. Let me ask, do I have a suggestion as to what negative 100,000 will give me? Negative 100,000, what will it give?
0.99995.
Good job. Very good. And that limit tends to what again, Shamari?
Yeah, as it tends to infinity.
No man, yeah. What's the answer tends to?
Extending to 1 as well.
Very good. So we say that it's of a good behavior since the limit from the left-hand side and the right-hand side are both tending to 1. So the limit of that function, x as x tends to infinity of x over x minus 5, the limit is tending to 1. The limit is tending to 1. All right, fair enough?
Yes, sir.
Yes, sir.
All right. All right, cool, no problem. All right, so graduate, can you speak now or are you still traveling home? So maybe he's still traveling. All right, so let us look at the calculations approach. Let us look at the calculations approach. The calculations approach is me saying to you, the limit of this function extending to 5 of x plus 1 over x squared. I'm saying to you, that limit is approaching 5. The limit is not 5. It is only approaching 5. So instead of using the intuitive approach where we investigate from the left-hand side and we also investigate from the right-hand side, we're only now going to assume that the value of x is equal to where the limit is tending. And we're going to substitute that value into our function. And then we're going to substitute that value into our function. What I'm going to say, the limit as x tends to 5 for the calculations approach. Anywhere in the function x over x plus 1 over x squared, I see x, I'm going to substitute 5. So I'm then going to have now 5 plus 1 to give me 6, and 5 squared is equals 25. So remember, we are assuming that the value of x resembles the limit, what the limit is equal to. All right, it's very important. The limit is not equals to 5. X is not equals to 5. It is merely approaching 5. So since it's approaching 5, we're going to assume that x is equal to that number. When we're using the calculations approach, that's what we do. Now, if you go into the exam, I've seen some crazy stuff. I'm giving students specific instructions. For example, using first principles to do the differentiation. And people are using regular differentiation. And of course, they get 0 because the instructions are not followed. So if they say to you, by using intuitive approach, evaluate the limit, you have to use the intuitive approach. What's the intuitive approach, sir? The intuitive approach is that when we investigate both the left-hand side and the right-hand side, and if both limits from the left and the right are doing what they're supposed to be doing, we say that the limits are of a good behavior, and it is tending to, the answer is tending to what the limit is rounding off to be. All right, remember also that the limit doesn't have to round off. Like we have the 0.995, we could have a limit running off to 3.499. And if it is running off to 3.499, what do you think the limit is tending to? That's a question.
Limit to 3.5.
Thank you very much, Shamari. Clearly, you're alone in the class, Shamari. I mean, I know there are other students in the class who are not speaking, and I know why they're not speaking, but clearly you're alone. But never mind. You will get your A, sir. Fret not. All right, so continuing. So if I look at the limit here as x tends to 0 of x squared plus 5 over x minus 1, again, I'm assuming that x is going to be equal to 0. So anywhere in the function I see x, I'm going to substitute 0. So I'm going to have 0 squared plus 5 is 5, and 0 minus 1 is minus 1, and 5 divided by minus 1 is negative 5. So the limit of that function tends to negative 5. So yes, when we use the intuitive approach, the question is longer. When we use the intuitive approach, the question is much longer. The intuitive approach, however, has its applications, because when I move into piecewise functions, you must use the intuitive approach at some point in time. At some point in time. Matter of fact, all the time. Because you're going to be given a range, and one is going to turn one way, one is going to turn the other way. It means that we need to investigate both left-hand side and the right-hand side. So be warned. All right. Let us see if we can continue. The limit as x tends to negative 4 of x squared over x minus 4, again, using the algebraic approach.
Oh, God.
Utterly mute. Utterly mute. Shamari, can you give me back the guest host, please?
So could you walk me through how I do that?
Yeah?
Could you walk me through how I do that?
You're supposed to have 3 dots there. Click on the 3 dots, and then it says assign host key, and then it's click on my name.
Alright, looking for it now.
Psalm 33, verses 6 through 5. I'll be reading from the ESV. And the word of the Lord that heavens were made, and by the breath of his mouth all their hosts. For he spoke, and it came to be. He commanded, and it stood firm. Then he saw and what?
All right, thank you, sir. All right, so anywhere in the function I see x, I'm going to substitute negative 4. So I'm going to have negative 4 squared over negative 4 minus negative 4. Negative 4 squared, remember, when I multiply two negative numbers, I get a positive number. So negative 4 times negative 4 is going to be positive 16. Positive 16. And then I'm going to have negative 4 minus 4 is negative 8. 16 divided by negative 8 is equal to negative 2. So the limit there tends to negative 2. So the point is, and I hope it's taken home, once you're doing the algebraic approach, what we're going to be doing in the algebraic approach is whatever the limit is tending to, we are going to assume it to be equal to x. And I'm using the word assume because it is not equal to it, only tends to it. It means that it only approaches it. But I'm going to assume that it is equals to it. And that value I'm going to be substituting into my function and evaluate the function. And that is going to be the limit of the function. Now, there are going to be some cases where you are asked to do limits, and it's when you evaluate those limits, you're going to get the indeterminate form. And that indeterminate form is going to be 0 over 0. Anytime I get to this topic, I always say to students, if you only check to see that the function is indeterminate, and you say that the answer is 0 over 0, you get 0 mark. The indeterminate form tells you that there is something in the function preventing the true limit of the function from coming out. And therefore, we need to do either a factorization, a simplification, or a rationalization in order for me to determine, to isolate what is causing the problem so that I can determine the true limit of the function. So once you get the indeterminate form, we do one of three things: factorization, simplification, or a rationalization. That performing one of those three duties will cause the issue to be repaired so that I can get the true limit of the function. All right, so that's what it is. So now, substitute for me, please, 3 into the numerator and denominator, all of you, and tell me what it is that you get for your outcome.
Sir, I got 0 over 0.
All right, thanks so much, Simon. So 0 over 0, and 0 over 0 is known as the indeterminate form. So it means there is something that needs to be done. There is something that needs to be done. So when we did the 0 over 0, when we substitute our 3 squares equals 9, and negative 5 times 3 is equals to negative 15. And that gives us the 0, well, plus 6.
Yeah.
So we're going to get the 0 for the numerator, and negative 3 minus 3 is going to be equals to 0. So we end up getting 0 over 0. We end up getting 0 over 0. All right? Now, we now need to do something. We now need to factorize the numerator because we recognize that we now have the indeterminate form. Once we get the indeterminate form, it means that there is something that we need to do. What do we need to do? We need to know, in this particular case, we're going to be factorizing. We're going to be factorizing in this particular case. So the coefficient of x squared is 1. How do you know that, sir? The number in front of x squared is 1. The number in front of x squared is 1. So the coefficient of x squared is 1. I'm going to multiply the coefficient of x squared by the constant, and 1 times 6 is going to be 6. I need two numbers. When multiplied together will give me 6. But when added will give me a negative 5. What two numbers come to mind?
Negative 3 and negative 2.
Very good. So the factors are negative 3 and negative 2. So the factors are negative 3 and negative 2. So therefore, I'm going to replace the middle terms with negative 3x and negative 2x. Negative 3x and negative 2x. So we're replacing it with negative 3x and negative 2x. Then we're going to be grouping. We're putting the first two in a parentheses, We leave the middle sign out every time. Every single time we are going to be leaving our middle sign out. And then we're going to put the last two in parentheses. There is a trick now. Once the middle sign is a negative sign here, you notice that this sign up here is a plus sign. We have to flip it right here. So this now has to be a negative sign. And another thing is, whatsoever sign that is in this bracket here has to be the same sign in that bracket. So both signs in the brackets should be the same, must be the same. All right? Then, sir, how you just go ahead and just flip the number like that? I actually didn't, I actually calculated it. Negative 2 times x, 2x is negative 2x, and negative 1 times 2x is negative 2x, and negative 1, which is here, times a negative 6. When I multiply two negative numbers, I get a positive number. So this is going to be positive 6. All right, so that's why I had to flip it. And then I asked my question, what is common here that is common there? And the response to me should be x. What is left? Has to be a x. Because when I multiply x by x, I'm going to get x squared. And then what is common between, when I factor out the x from negative 3x, I'm going to have negative 3. And then I'm asking myself the same question here. What is common between 2x and 6? And you're going to say to me, 2. So I factor out the 2. What is left? It's going to be just the x. When I factor out 2 from 6, I'm going to get 3. And then you'll recognize that the x minus 3s are common. So I can factor out my x minus 3, and then I'm going to be left with x minus 2. So my answer will be x minus 2 times x minus 3. X minus 2 times x minus 3. And with that, I'm going to resubstitute into my original question given. My original question. So instead of putting x squared plus minus 5x plus 6 in the numerator, I'm going to put x minus 2 times x minus 3, my factorized term. And when I look at my denominator is going to be x minus 3. And at which point I recognize that the x minus 3s can cancel. And then now I apply the algebraic rule. Wherever the limit is tending is what I'm going to use as my x value to substitute into the function. So the limit is tending to 3. So I'm going to have 3 minus 2. And 3 minus 2 is equals to 1. 3 minus 2 is equals to 1. All right? Take a minute and look at that for me, please, and give me half a second. Are there any questions?
All right, so the
Yes, sir. So, can you hear me?
I'm hearing you, Shamari.
So, whenever we get, at what point did you say we do the
All right.
factorization
Sorry. 1 minute. Mute from me, please, Shamari. Mute from me, please. All right. So I'm going to ask you, Shamari, is it possible for you to just maybe step away from that television, or is it possible for you to turn the television down? Because I want you to be able to hear my responses and that others can hear what it is that I'm answering. Is it possible?
Yes, sir.
All right. And when you have, you can. Oh no, he's gone.
Is that better, sir?
So I have a question for you.
All right, run the question.
How do you put these two ideas together?
I was asking if it's only when we get to do the indeterminate of the function that we work it out by factorization and simplifying.
No, not
Could we
necessarily.
just go,
Not necessarily. So sometimes I can give you another function that is well, yes. Because if so it's when it is indeterminate that we will go through this with this stage, because had it not been indeterminate, we wouldn't have had to do the level of factorization that we're doing now. Follow me?
I think so, sir.
Come on, cool. All right. I'm gonna stop share. This thing is not allowing me to write. And I need to write. All right. Are there any other questions? Okay. So let us look at this question here. The limit as x tends to 4 of x plus 1 over x squared minus 1. Can you check for me, please, to see if this is indeterminate? Check for me, please, to see if this is indeterminate.
Sir, it's not indeterminate.
It's not?
No, sir, I got 1/3.
Excellent. Everybody agrees with that?
Yes, sir.
Good job. Check. So since you did not get 0/0, Shamari, you asked a question earlier. So since you did not get 0/0, it suggests that the question is not indeterminate. Therefore, no need to factorize, simplify, or rationalize. Question is done. Period. You see that, Shamari?
Yes, sir, I get that.
All right, good job, Papa. All right, now I want you now to try this one. No, I want you to try this one.
This one is indeterminate.
Very good. Something just came to mind a while ago. And let me say it. Whenever you get a question and the question looks like it is of an indeterminate form, don't just assume that it's indeterminate and start factorizing. Because if you had done that for question 2, you wouldn't have gotten the correct answer. You wouldn't have gotten the correct answer. I want you to go ahead and first try the indeterminate form and then, test it and then do what it is that you need to do. All right, continue working for me, please. What I want you to do, I want you to try and finish off the question now. Yes, it is indeterminate. I want you to finish off the question quick and fast. Oopsie daisy. Oh, but I don't even have the answer there because I want you to do that quick and fast for me.
The answer -1 over -1/2.
You said -1 over -1/2.
No, say -1/2.
Oh, -1/2. All right. Anybody agrees with Shamari?
I agree, sir.
Thank you. So since I don't have the answer for that, let me just go ahead and work it. So it says the limit as x tends to -1 of x plus 1 over x squared minus 1. When I substitute -1, I'm going to get 0 there. -1 squared is 1. 1 minus 1 is 0, indeterminate. And since it's indeterminate, now I'm going to do a small procedure And I recognize the denominator to be the difference of squares. That cancels this. I must write my limit here, extends to -1. So I'm going to end up with 1 over x minus 1. So anywhere in the function I see x, I put -1, I'm going to end up with 1 over -1 minus 1 is equals to -1/2. So I agree, you're correct. -1/2 is correct. Everybody saw it. Tristan, you're not speaking to me. Tristan, are you there?
Yes, sir. Yes, sir.
Virgin, unmute and talk to the animal. My wife will respond to me, man, Tristan. Please respond to me. I need to know that you're understanding, Papa. Rajay, can you speak now, Rajay? Are you home, Rajay? And Rajay is not in class. All right, let's go. Very good. Excellent. Excellent work. I want you to try that one for me, please. Number 4. Numero cuatro. Number 4. Try that one for me, please. Quick and fast. I'm waiting on you guys here, please.
Minus a half, sir.
Thank you, Astamir. Everybody agrees with that, or okay, continue working. 2 more minutes.
Yes, sir. I
Shamari,
agree.
you agree? Good job. Minus a half is correct. Excellent. Simon, what say you?
Yes, sir, I agree.
Okay. All right, one last one, and then I move into something else. Number 5. Or we stay?
Fortunately for me, I don't remember how to factorize that one with a coefficient in front of the two, in front of the x square.
Same way, man. All you're going to do is multiply the coefficient of x squared by the constant. So you're going to say 2 times 3, 6. So what you need to find are the factors of 6 that when multiplied together will give you 6, but when added will give you positive 5. So you multiply the coefficient of x squared by the constant.
Oh, okay.
Right.
Sir, I think with this one, X is gonna have more than one value. Or two values.
You got 2 values for this one.
I think so.
Is it indeterminate?
Yes, it was.
Yeah. So when you get 2 values there,
Okay.
when you factorize, then get 2. When you say 2 values, you get like x plus something and x plus something. That's what you talk. That's what you call 2 values.
X being -1 and terminal.
Astenil, I don't want that. Say what it is that you're saying. Complete your thought.
X X be 1 and X be at 2.
Okay. So what I don't want you to do is to go and solve it because it's not an equation. I want you to just go ahead and factorize it. And then you're going to cancel out the ones that are common, and then you're left with something else. That's why I wanted you to complete your thought. You follow what I just said a while ago, Asinine?
Yes, sir.
Shamara, how far you reach now?
So I think I get x plus 2 multiplied by x plus 3 over x plus 1.
Look over that again for me,
I
please.
got what he got except for the whatever I have on the over, the top part.
Oh. That's what I got for the top part. Look at it and tell me how you feel.
Fair enough.
What was that?
A bit thrown off.
But you see what I got that?
I'm looking at it again.
So we multiply the coefficient by the constant, you should still use the x square as is and not just use the x square, removing the 2.
No, I'm not following it. Let me
So-
work. Then go ahead, go ahead.
When I multiplied the 2 by the 3, I started disregarding the 2 that's in front of the x square. I just worked with it as x squared plus 5x plus 6.
No, you have to keep it.
Okay, sir.
Sir, can you work through this one, please?
My pleasure. So I'm going to have 2x squared plus 5x plus 3. I'm multiplying the coefficient of x squared by the constant. So 2 times 3 is equal to 6. I need two numbers. When multiplied together will give me 6. But when added will give me 5. So the factors are 2 and 3. So I'm going to say 2x squared. So it's Shamari, I'm keeping it. So I'm going to say 2x squared plus 2x plus 3x plus 3. Then I'm going to group 2x squared plus 2x in one bracket. Always leave the middle sign out every time. 3x plus 3. What is common here, that is common there, will be the 2x. What is left is going to be x plus 1. And what is common there, that is common there, is going to be 3. What is left is going to be x plus 1. And you can recognize here now that my x plus 1 and my x plus 1 are common. So therefore, I'm going to factor it out. And what I'm going to be left with, 2x plus 3, which is what I got here. Look at that and tell me if it clears up anything or if it makes it worse.
Clear it up, sir. It's just because I did factorization a long time ago.
And that's fine. And that's why you're here now. So I don't feel any way about it. I mean, I'm happy that you're seeing it now. Yes, Asin, I heard what you said. Cleared up. Very nice. Rajay, can you speak now? Simon, me now want to call to you every time, and I want to hear from you, Simon. Talk to teacher, Simon.
It's all right. I see how you got the number 5.
All right, thank you, Pops. And then now, what I'll do is to divide both sides by, the x plus 1. So the x plus 1s will cancel. And when the x plus 1s cancel, anywhere in 2x plus 3, I see x, I put -1. So 2 times -1 is going to be -2, and -2 plus 3 is going to give me my +1. So that's why my answer is equals to 1. Do you all see that?
Yes, sir.
Yes, sir.
Good job. Good job. Um, Mm, 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 mm. We can do that for homework. I need to just put another one on the thing so that I can see that you are understanding. Ah, give me half a second. Let us generate another question for you. All right, there goes another one.
Class, just start or start long time.
What about good afternoon or good evening?
Oh, good afternoon. Good evening. I did not remember this class. It's not on my timetable. I keep on a look on it and I wonder what I'm missing.
You have to use the timetable what Miss Campbell sent in her email.
Yeah, but it's not on it for me because sure, whenever I feel like I go do the class, I never the have the timetable.
Are we okay?
Still trying to figure out the numbers that I'll be using in the factorizing section.
What number, what is the product that you're trying to work with?
Minus 15.
Good job. So you need two numbers and multiply together will give you minus 15. But when you add those two numbers, you're going to get positive 2. How is still? How is still? How is still? How is still?
So I'm stuck. So when I'm supposed to go, I can't find what's similar with the second bracket. Or maybe I can. Hold on a second.
3 into 15 volts.
5 times.
And then move on to the next prime number. We're prime factorizing.
1.
So my factors are going to be 5 and 3. But I need a positive 2. So since I need a positive 2, it means that the bigger number has to be positive. So my factors, therefore, are 5 and negative 2, negative 3. These two numbers, that is. 5 times negative 3 is negative 15. And 5 plus negative 3 is positive 2. Agree?
Yes, sir.
So I'm going to group. Next group, I'm going to get 3x squared plus 5x in one bracket. Leave my middle sign out every time. Remember, when I leave my middle sign out, I'm going to flip the last term. Please note. There's a flip in those. What is common here that is common there? It's going to be x. What is left is going to be 3x plus 5. No? And what is common here that is common here that is common there is going to be negative 1. What is left is 3x plus 5. What is common to both is 3x plus 5. What is left is x minus 1. So what I'm going to do now is to say the limit as x tends to 1 of 3x plus 5 over x minus 1 all over x minus 1. And if you look at it, the x minus 1s will cancel. So what I now have is just 3x plus 5. And I'm going to substitute my 1. Look at that. Am I correct? Do you understand?
Yes, sir, I now understand what I was doing wrong.
Okay. Shamari, where is the Papa?
Yes, sir, that's what I got.
Good job, Papa. All right, let me give you a 5 minutes break, and then we can just run it for the last couple. I'll give you a 5 minutes break. And go and get some water, refresh yourself, restroom, whatever the situation is, and then come back to me. 5 minutes. All right, we're going to be joining back in another minute or so. Join back in another minute, all right? So come back. All right, are we back?
Sir.
Okay. Shamari, are you back?
Yes, sir, I'm back.
Good job.
Sir, Talia said she's at the doctor's office, so she'll be late.
All right, thanks so much. All right, so what we're going to be looking at now, so we have many different types of indeterminate form. We've just been introduced to 0 over 0, but we could also have an indeterminate form as positive infinity over positive infinity. And we also have another one, which is negative infinity over negative infinity. All right, so you now know how to evaluate the indeterminate form, 0 over 0. I'm about now to show you how to evaluate the positive infinity over positive infinity. So let us look at that function. The limit as x tends to infinity of x to the 4 minus x squared plus 7 over 2 x to the 4 minus 6x cubed plus 2. So we are evaluating the limit. Now think about it. I want you to think. And it's not a biggie, but just think about it. If I have x to the 4th and my x value is infinity, that infinity raised to the 4th power, do you agree that it's going to be a bigger infinity?
Wait, sir, can you
Now I'm
repeat your
saying
question?
if I have x to the 4th, if I raise infinity to the 4th power, do you agree that I'm going to have a huge value there?
Yes, sir.
And if I minus the infinity square from it, I still will have an infinity square. I'm going to plus 7, I'm going to still have a bigger value. So the point is, when you look at those values there, you know that you're going to be of the indeterminate form, infinity over infinity. Looking at that still tells you that you're going to be of the indeterminate form, infinity over infinity. Now, whenever you get that, you're going to look through your function numerator and denominator alike. And you're going to look for the term with the highest value, the highest power. You're going to look for the term with the highest power. Now, the highest power there is going to be x to the fourth. Can you agree with me?
Yes, sir.
All right. So because I've identified x to the fourth as being the highest, I'm going to be dividing each term in the numerator as well as the denominator by x to the fourth. Each term in the numerator as well as the denominator by x to the fourth. Tell me if you agree with what I have on screen.
Where does it be that from the term?
Now I'm dividing each term by x to the fourth. So x to the fourth is a term that is the highest one, the largest one, x to the fourth. So I'm going to divide throughout by x to the fourth.
So if there was an extra 5 in the numerator, we would divide everything the numerator and the denominator by x to the 5.
Very good. Yes, sir. Yes, sir. All right. So that's what we'll do. And then we're going to do some cancellation. Look at my cancellation, tell me if you agree with it. If not, say something I can go through with you. Agreed?
Yes, sir.
Good job. Astanil. Astanil. I'm going to sleep. All right. And then now, remember now, I want you to note x to the second power divided by x to the fourth power. See, I draw it out here. I'm going to have x squared, and x squared times x squared is giving me x to the fourth. So I'm going to end up with 1 over x squared. So that's why I end up with this 1 over x squared here. All right. So I want you to look at it one more time. And x to the third over x to the fourth, it means that I can break it up. I can have x to the third here and x to the fourth. I can take 1 and x to the third out of it times an x. So I'm going to have 1 over x left. I'm going to have 1 over x left. So that's why I end up with the 6 over x. Now, are you with me so far with that? If you're not, let me know. Let me go back. Look at the progression and let me know.
Understood.
Sir, could you scroll up for me, please? Okay.
Mhm. And then when I would have reduced them with my cancellations, then I'm going to say as x tends to infinity, the 1 over x squared, the 7 over x to the fourth, the 6 over x, and the 2 over x to the fourth will all tend will all tend to 0. Will all tend to 0.
Explain that part.
All right. All right, let me just. All right, so let us look at it. Yeah, the 1 over x squared, which is here, 7 over x to the fourth, which is here, the 6 over x, which is here, and the 2 over x to the fourth, which is here. And I'm using some values over here for x that I'm going to be using to investigate the behavior of it. Now, when x is 10, I'm going to investigate what happens to all these terms. When x is 10, I'm going to have 1 over 10 squares. That works out to be 0.1. When x is 10, I'm going to have 7 over 10 to the fourth. X is 0.0007. And x is 10, I'm going to have 6 over 10, which is 0.6. And finally, when x is 10, I'm going to have 2 over 10 to the fourth. I'm going to get 0.0002. You see that these numbers are not whole numbers. They are going to, they are decimals in this case. Of these 4 functions, which one or ones is moving to 0 quicker?
The one with 7.
Is that the only one?
The one with the 6.
Really, Ashley?
You said quicker, sir.
Right. Which one is moving to 0 quicker?
0.01.
You are guessing.
Yes, I am.
Okay. Because going to 0 would be the 7 over x to the fourth, which was the first response you gave me. But there's another. But I asked you if there was another, and you gave me something that is not correct. So I'm saying to you, the 2 over x to the fourth is also going to 0 quicker.
And
So
then that be the one, that the 6 and then the 1.
no, the 1 and then the 6.
Oh, because it's 1 decimal place.
Right.
For some
Right.
reason, I was seeing more than 1 decimal places for the 6.
Okay. Right. So if we investigate the 1 over x squared, what does that mean? When x gets to 100, we'll go to 0.0001. And when x is 1,000, 0.000001. And when it's 10,000, it's 0.00000001. So as x gets large, the function goes to 0. Can you see that? As x gets large, it gets large going down this way. The function goes to 0. As x gets large, the function itself goes to 0. So that's why I'm able to say this. That's why I'm able to say that. As x tends to infinity, the function goes to 0. Or the functions go to 0. So what is going to happen is I'm going to have 1 I'm going to have 1 minus 0 plus 0, see it here, over 2 minus 0 plus 0, and 1 over 2 is the same thing as a half. And that's my final answer. Any questions?
No, sir. I know you're probably gonna give us one to work now, but I just came back. So could you run back through this again, if you don't mind?
I don't.
Or run through another question?
Shamari, are you here?
Yes, sir.
Do you understand what is on the screen?
Yes, sir.
All right. Killing 2 birds with 1 stone. I am going to ask you to explain to the class what is on screen here for me. But remember, I am watching. So make sure everything that you say is correct. Or else you have to pay me. All right, let's go. So I want you to explain in the best way possible, so that your classmates can understand what is happening. Start.
All right, so the first step would be to identify the largest exponent within the numerator and within the denominator. So we can see that the largest exponent that we have there is 4, x to the 4. So what we're gonna do, we're gonna divide each term in the numerator as well as in the denominator by x to the 4. So the third step, at the third step, that's where we cancel out the like terms from the division of the x to the 4. From the division by the x to the 4. So as you can see in the first term, x to the 4 cancels x to the 4, so we're just left with 1. In the second term of the numerator, we have x to the 2 as the numerator and x to the 4 as the denominator. Right where you see the note, sir has simplified it for us, showing us that x to the 2 as x to the 4 can be written as x to the 2 multiplied by x to the 2 x squared. And so once you cancel the x squared from the numerator, you're gonna be left with 1 essentially. And then you're gonna have an x to the square, x squared left in the denominator for the second term. And the third term is left as is since there's nothing to cancel. And so we did that same process for the denominator. The first terms cancel out each other, leaving the 2. And we have in the numerator of the second term x cubed, and that would be cancelled out by an x to the 3rd in the denominator, because x to the 4th power can be written as x cubed multiplied by x. And the third term will come back down. So what happened at this stage, that as in the next stage, was he singled out the terms with x inside of it, and we plugged in some values for x, calculating if calculating the limits essentially by the intuitive approach. So we used 10 since we're talking about infinity. We're using I guess tens, not tens, but we want to see how x behaves as we get larger. So the best numbers to use are multiples of 10, as you can see in the chart right there. And so since as we increase the value of x, it tends to get more towards 0. So what we did, we plugged in the 0 for the x in the expression. We worked it out and we got a half as the limit for as x tends to infinity of that expression.
Thank you, sir. Aston, how it feels now?
Yeah, that refreshes my memory, so.
All right, very nice. So let me just point out something here. Very good, Shamari. Let me just point out something to you here. When you reach this stage, I don't necessarily need for you to see this intuitive approach. You should know it. I know what it's supposed to look like. So when you reach, I'm only doing this as a proof. See, I put it here, proof. So I don't want you to go and do this. I'm only doing this because this is the first example that I'm working with you. I would want you to be able to recognize when you reach this stage that once I have my rational function with a constant in the numerator and a variable alone in the denominator, that as x gets large, these functions will go to 0. So I'm expecting it to move from here to here and then directly here. I was only proving to you right here what is happening so that you can get a fulsome understanding. All right, with that said, let me see you give an attempt on this one. I'm giving you what the answer is. I'm telling you that the answer is 1, and I want you to work it out to let me know if you get 1. So you know what answer you're working towards, because the answer is 1. So start working for me, please, quick and fast, as well as accurate. Always stay.
Feel like we stay good in the surf, or me stay good.
I absolutely love the sound of that. And you got the one?
Yes, sir.
Very good.
Like,
Aston, go ahead. Come on. You're saying? You're saying something else?
so since I skip, you say we should skip out the chart section.
Yeah,
So
yeah, yeah, yeah,
once
yeah.
I get the figures, I just plug in 0 and work it out.
Plug zero where?
For X.
You
As
have
in,
those?
yeah,
Yeah, yeah,
what's
yeah,
up?
yeah. So you can have one minus zero,
Yes, sir.
right here. So,
Yes, sir. Yes, sir.
yeah, man. You know that. Aston, how you feel?
I guess you were calling me, but I wasn't at the device. I got the one, sir. And I got the 1 minus 0. Minus 0 over 1 plus 0.
Good job. Simon.
Yes, sir, I got the one.
Good job. I want you to see if you can do these by inspection. I put the answer there, but I want to see if you can look at those and see if you see any strategy that you could work to by inspection and look at it to see if you see the answer. Let me put some others there. Yeah. So I look at those three and tell me to see if you can come up with something to see what is happening.
No, sir, I'm not singing.
You're not? Oh no. Look again, man. Shamar, are you seeing anything?
I think I'm lost at the moment, sir. I'm, yeah, I think I'm lost. For number 9, I was sorry about that. For number 9, I was like plugging in infinity into the for x's to see like I should find out if it's indeterminate at first.
Mm. No, man. Remember, I say I want you to do like inspection. So I don't want to do no calculation. I don't want to plug in anything. Look one more time, please. All of you. Look. Look. Just look at what I have on the board. Just look at what I have. Look at the first example. Look at example. I don't want to highlight it
Go to
because
another example, sir. Let me see if it's what I'm thinking.
what's the answer for number 11?
So, sir,
Mm.
while I can see the response for 9 and 10, I'm not seeing it for 11.
I know, because I want you to tell me answer for 11. So tell me the answer for 11 and then I scroll down for it.
4/2. But why I have positive?
No, hold on, no, man. Just work with me, no, man. So what is 4/2, Astimil?
Huh?
What is 4/2 in its simplest form?
One. What's up?
You gotta be joking.
No, sir. It's 2/1, sir.
Which is?
2.
Okay. So do you think you see it now?
Yeah.
Shamari?
Present, sir.
Hmm? You don't see it yet?
Can I ask what I saw?
No, not yet. As I'm coming, I just want to hear Shamari. Shamari, what say you?
Still lost, sir.
Still lost. All right. Simon, what say you?
Sir, I'm all right. I'm just need to get the work in out done. So
No, I don't want.
in case of
I don't want. No, hear me out. I didn't ask you to work it out. I don't want you to work it out. What I want you to do is to look at it and tell me if you can figure it out by inspection. I worked out that one because Aston she asked for another example, but I was going to give you that one there. So she asked for another example. All right, Aston, let me hear what you say. Go to
the coefficient of the numerator with the highest power over the coefficient of the denominator with the highest power.
Do you agree with that now, Shamari?
Yes, sir.
Simon?
Yes, sir.
You agree with what she says?
Yes, sir.
Alrighty then. Correcto. Very nice. Excellent. Excellent. By inspection, tell what the answer is for number 12.
Three, sir.
3, 3, 3, 3. Anybody agrees with her? She says 3. She says 3. Anybody agrees with her?
I agree.
You agreed? Shamari agrees? Who else? Talk to me. Háblame. Talk to me.
Which language are?
Spanish.
Oh, you say háblame. Me think you say háblame.
Mm-mm.
Sorry, can move.
I disagree.
It's alright.
Yes, Sam, what you saying?
So I was going to say 1, but
Yeah, I still disagree. I don't agree with 1 either.
What's your answer?
What's my answer?
Mm-hmm.
My answer is gonna be Zaro.
What?
Zaro.
Okay,
0.
let's see. Oh,
Look at it. Look at the solution. And then I want you to be able to tell me a rule. You should just like what you told me a rule a while ago. I want you to look at that and then I'm going to ask you a rule.
when the numerator has the largest power, we divide all terms by the highest power.
When the numerator has a highest score, does the numerator?
Denominator. Sorry.
Okay.
Mm-hmm.
So when the denominator has a highest score, what will happen?
We divide all terms by the highest power.
No, not only that. The general rule is you're going to divide throughout by the highest the highest coefficient,
Mm-hmm.
the highest power exponent.
Mm-hmm.
So that's a general rule. But tell me, me too, sir. I was going to tell you that before you asked me, but yes, me too. I want you all to look at it. Simon, Astonil, and Shamari. Abraham, come talk to me, no man. Don't let me drop asleep. Is Tristan
Yeah,
here?
I don't see a rule that I can develop from my
It don't say,
observation.
it don't say a rule. The
Other
rule is
than the
right
highest
there.
power, and then when x tends to infinity, we have each term going to 0. But I'm not sure how to tie in that with the highest power being the denominator, because that's the general rule. Denominator or numerator. So I'm kind of out of it for this one.
Shamari, you going to bed now, Papa? You burn out now, Shamari. You're firing on 6 cylinders and now you're not firing on one of them. Seem like you not answer.
That is true, sir.
All right, we soon finish, man. In
So
another.
you're stressed out the young man brain. So go and
No, but
relax.
guess what? And you know what is happening for him? He's
Mhm.
watching the videos because based on the questions that he's asking me, and he's saying that he's doing the course for the first time. You're doing the course for the first time, right, Shamari?
Yes, sir. And I
Right.
didn't get to watch any more videos, so I
Yeah.
would need to, like, before, when this class finish, I would like to know the next topic that we'll do, or if we're going to the same one again.
Sir, the denominator with the highest power result is 0.
Duh, 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 duh.
Sorry.
What do you expect? Very good. Let me ask you something here now. What do you think that answer is? Based on what you just told me, what do you think that answer is?
0.
Okay. 0. Think. You see the man right here, so? Him up here, so? He must think, he must investigate the one here. You notice we're not doing any calculation, we're just doing the my inspection now. Because we turn bright. So look at Utterly gonna bed, you know. He said Utterly gonna good bed, man.
I'm there right here. Man.
I threw my friend here while I get drum up Utterly. You're gonna good bed.
No, sir.
Utterly you never link that student for me, no? I bet you. You didn't link her again?
Sir, me link arm, sir, what she work, I mean, work as stress, sir.
Oh, Jesus. All right, let's soon wrap up. We'll wrap it up in another 5 minutes. Well, yeah, 5 minutes. Providing that you get this one, because when we finish this one and we chit chat a little bit, we wrap up. What do you think number 14 is?
6 over 0.
6 over
Undefined.
0.
Or
Why is it
undefined.
undefined? I hear you change your mouth and say undefined. Why is it undefined, Simon? Why is it undefined, Aston?
Because the denominator is 0. When the denominator is 0, it's undefined.
That's what I like when I teach and students learn. That's what teaching is all about. Teacher teach and students learn. That's what happens, should happen. When the teacher teaches, the student should learn. Shamari, did you hear what you said a while ago? Or should that one to be undefined?
I need an explanation, sir.
You need an explanation. That's what you said a while ago?
Yes, sir.
Okay, Aston, your turn to explain to him now.
Answer mega explains.
Listen to me, lady. Don't play with me. Explain something. Sure.
So you can scroll up on it, please.
Absolutely.
So we are doing this by inspection and we are looking at all the terms that are given, right? So we're first finding the largest term, whether it is in the numerator or the denominator, and we're applying the general rule where we're gonna divide each term by the highest power or exponent, as you guys call it. Which is, in this case, it's, give me a second. I'm sure you're in my background. Just a second. Sorry about that. In this case, it's x to the fourth power. So we're gonna divide all terms by x to the fourth. So that's step 2. And we know, normally we would recall, so sir would say, where we minus the powers, and we have what's remaining in step 3, which is 6 plus 25 over x. That's step 3 right there, based on the above calculation. Now we know from previous questions that when x is tending to infinity, we have each term, which is 6. Sorry, can I scroll down, please? So we have each term here, and we know that when each term is tending, when x is tending to infinity, each term is all going to 0. So we have the whole number, which is the coefficient. So we bring back the 6 here. This is the step 3, 4. So we bring back the 6. And then because each term is tending to 0, which I think you would understand here, that 25 over x would be 0. Then we have minus 0. We have the denominator aspect, where we have 0 plus 0. Now, we have, okay, I think this is easy to simplify because you have 6 plus 0 minus 0. Basically, 6 is untouched. So have the 6 and then the new denominator is 0. Now, we say it's undefined. From previous question, we say it's indeterminate. Yeah, it's indeterminate when it's 0 over 0. It's undefined because we can't bring it any further because we have no denominator to bring it any further. So we say it's undefined. If you understand, you can say that you understand. If you don't, I'll try to go a little further, maybe, or maybe not, or sir can just explain. Okay.
All right. So remember, when it's undefined, the denominator is equal to 0. We can't have a 0 existing in the denominator. So whenever we have a 0 in the denominator, we say that it is undefined. A 0 cannot exist in the denominator. Not at all. Not today, not yesterday, or ever. So once it is that we have a 0 in the denominator, we say that it is undefined. All right? So good. Thank you for explaining all of that, Austin. What I wanted you to explain is looking at the question by inspection. How could I have told you that this function, this limit, is going to be undefined? Just like we did for the others, how can you look at it and tell me that, hey, sir?
Because the 6 is attached to, the 6 is the coefficient that's carrying the highest exponent.
So the highest exponent is where?
It's in the numerator.
Okay. So when the highest exponent is in the denominator alone, your limit works out to be what?
Zero.
Very good. And when the highest exponent is in the numerator alone, your limit works out to be?
Undefined.
when the highest exponent exists both in the numerator and the denominator you have?
No, I think this is where we divide the coefficient by, I think this is where the general rule applies.
Have a fraction.
Very good. You have a fraction of the numerator and the denominator. Who says math wasn't fun? So
Yes,
mathematics.
the same still applies.
What's saying that the numerator, when the highest was in the numerator, you're going to have undefined.
No.
No, that's the only one I'm going to apply. All right. You think I don't know where you're going, but I ain't going there with you. All right, we're going to end right here tonight. We had a slow start. I just need to get some things out of the way. We had a slow start. Slow meaning I somewhat struggled to get you guys going. But towards the end of the session, you guys did exactly what it is that I wanted you to do and to accomplish. I think we accomplished the task at hand. I congratulate you for doing that. I, however, would gladly appreciate, come Monday, God's willing, for the remaining sessions that we have for this semester, that I'd prefer if I don't have to call upon you. I prefer if when I ask a question, you just respond to me. When you do the question, do you understand what does that mean? Yes, sir. I'm not in a face-to-face class. The strategy has to be different. When I have to stop and call everybody in the class, it takes up time. We're doing a fast track program. But I also recognize that, I need to take my time. So I'm just going to ask you, and also it's twofold. When I ask you if you are following and I want to hear you respond, I don't know if you get up and go and do laundry and them something there, you're not paying me any mind. I want to know that you are always in front of the system, learning when I'm teaching. So going forward, please, because there's going to come a time when I ask, are you understanding? And I don't hear a response, and I just continue working. And that is going to be to your detriment. That is going to be to your detriment. So I'm going to ask you, please, come next week, God's willing, when I ask a question, you respond to me. You unmute your microphone, and I'm not going to ask you to keep your microphone unmuted because you may have somebody come in and say something, and I don't necessarily want to hear what the person is saying to you. But for sure, though, when we are having that level of conversation, I want to hear from each and every one of you. Do we have a plan in that regard?
Capish.
All right. Are there any other questions of me? If not, I thank you for being in class. Go ahead.
The results and when is the fast track exam?
All right, I discussed the fast
Have you
track exam.
finalized on that?
Yeah, so the grades are in. The grades are in. The grades are in. I submitted the grades. However, there is something that needs to be sorted. But the grades are in, and I have a good enough idea as to what is going to happen. But yes, the grades are in. The fast track exam is going, I think I may go up until the last Wednesday. I believe, I think I said the last Wednesday. 6 weeks from, we're gone week 1 already, so we have 5 more weeks. It's a 15-week semester. 7 weeks. So we're in the first 7. So we have 6 more weeks to complete the syllabus. So we finished week 1 today. So count 6 more weeks and you'll get there. 6 more weeks and you get there. Please remember, guys, to select the courses. Please remember to also pay for the courses. By the time it's been 6 weeks, we can come. Please remember to complete your Editors I was disappointed with the Editors last term. Some people just never finished their Editors or finished and
Sure.
finished with some very low grades. Yes, ma'am.
Knowing that I finished my Educosoft, or I thought I did, would I still have to do it over?
All right, so my response to that question is going to remain the same.
But
Yes,
January not done it.
it's a new term. The profile that you were using last term is a different profile that we're using for this term. So each semester has its own profile.
That profile is currently open for this term.
Because of it would have been closed out today, but because of something that I recognize that I discussed with Mrs. Campbell. So by Monday for sure, you're going to see it closed.
Okay.
So that is the issue. But I will need to yeah. On Monday we can have conversations, or we can have a little conversations on this stuff. So yeah, so you and I can have a little chit chat, and we'll just take it from there. Big up yourselves. Have a wonderful rest of the evening, night, and have a good time. Remember, you need to go through your Edukasol from now. Students, let me just say this. When you would have done your exam, and me taking this 1 day or 2 days or the weekend to mark your papers, and I'm extracting the grades from Edukasol, any grade or lack thereof on the platform is going to be entered on a grade sheet. So we're not going to have a situation where, oh sir, can I finish the Edukasol at the end of the semester? No, the Edukasol will have to finish within the 7 weeks that we're talking about. Because I will have to extract your grades, because remember, in order for you to do Calculus 2, you'll have to pass Calculus 1. So I am going to be under pressure to mark the Calculus 1 in a couple of days to submit the grades, and then we start teaching Calculus 2. So for those of you who like to procrastinate and wait until the last minute thinking that we have enough time, I'm telling you from now, the platform is going to close out on you. And once it does so, you're going to get zeros, and it's going to pull down your percentages. What's the point? Start working now. Start working on your Edukasol pieces now. You don't have time to waste. All right? I'm going to send you a screenshot of the handout that was used for this week now, or in a few. And please, just be diligent and cover your work. Once you do your work, you must pass the course. Okay, have a good night.
Have a good weekend, sir.
Simon, can you call me right now, please, before I drop asleep? Thank you.
Yes, sir.
You take a